Hi roboticist! Let's kick off a new series on point cloud library tutorials that allows you to perceive the environment in 3D. And at the end of this tutorial series, you will be able to install a 3D camera like a Kinetic ones, process 3D environments using point cloud libraries, and develop 3D computer vision applications like object detection, recognition, geometry segmentation. We're gonna see what does it means, and much more that you can integrate these features in your robotic application, especially with ROS. So, for those who don't know me, I am Francesco from Learn Robotics with Ros. I am a robotics software engineer and a PLC programmer. And the scope of this channel, if you are new on this channel, is to learn how to program a robotics using a ROS framework or Robot Operating System framework. So the approach is not use a plug and play ready solution, but rather we try to deeply understand what, why, and how we are programming robots in a certain manner, in such a way to give you all the instruments that you need to deploy your own industrial robotic application. So if you want to get into this transformation, subscribe to the channel and we will do it together. And feel free to book a free call with me to tell me about your robotic needs or technical issues that you are facing in developing your own project for yourself or for the company you are working with. And furthermore, if you start from zero, I am developing a master program for becoming a robotic software engineer in ROS by developing industrial application. Now I am in the pre-selling phase, so if you wanted to check it out, I provide the link in the description down below. And now let's get started. So before diving into the code, let's first understand what a point cloud library is. Well, point cloud library, like OpenCV, is specifically designed to sense the 3D environments in points. So the environment is represented from points of 6 coordinates. 3 regarding the position in X, Y, Z, and 3 regarding the RGB data for the color. That's all. And the point cloud library has a lot of tools to manipulate these points and retrieve useful information for our robotic application, like detecting an object and its position and so on and so forth. So these tools that you can see from the point cloud org web page, like Octree, something that we have already seen, surface, key point, filters, geometry segmentation, etc. They comes from, let's say, a smart manipulation of these points of 6 coordinates, and we can use the tools that are most useful for us or better for our application. So if I want to give you an example, in OpenCV we have done a video so far, and we got a 2D image from a camera that was subscribing to the topic image raw. And if you remember, we have used the tools available in OpenCV to manipulate that image for our interest, like crop an image, create a mask based on the color, apply an edge detection, find the points of a square, and so on and so forth. And in the same way, in Point Cloud Library, we will get a 3D image from a camera. This time it will be a Kinetic camera, that can subscribe to the topic point cloud, and we will use the tools available from point cloud library to manipulate the 3D image from detecting the object that we want to pick. This is just an example. So, okay, that's all for this introduction, and let's write some code to kick off this PCL libraries series. Okay, so the first things that we need to do is to install a 3D camera in our environment. So the approach will be to modify our URDF file of universal robots, which is gonna be this one that you have available in the GitHub repository. I remember that I'm gonna provide the link in the description down below. And then we are going to as I said, modify the URDF file to install the plugins for the 3D camera. We are gonna see what will be the configuration of the topic that this 3D camera contains, and then we will redo the universal robot MoveIt configuration, and then we will spawn our robots in a gazebo environment with the MoveIt, and we're gonna see with Rviz, with the MoveIt plugin, what the camera actually sees, and we are gonna subscribe to the topic point cloud. So first, let's start to install the camera, and the approach it will be from bottom up, meaning that first we are gonna install in our package app YouTube the file that describes the camera in sense of DAE, PNG and STL file. Okay, so to do that, let's create another folder, and let's call it meshes. Then another folder, sensor, and in this folder let's put camera. Okay, so in this camera we will need to put the Kinetic DAE file, PNG, and the STL file that describe the geometry of our camera. So now allows me to do some copy and paste from my repository. Here you are. This is the file that's described at the lowest level from software point of view the camera, the Kinetic camera. And then in this folder, the camera, we are gonna put the PNG and the STL file. Now what we're gonna do is to create our chakra files to interface with the gazebo. So we will need the gazebo plugin for the camera, and the description to put our camera in the URDF file of our Universal Robot 5. So let's create inside the URDF folder, as a good practice, a folder sensors. So The point here is inside the URDF file we are going to differentiate between the robots and all the sensors that we might have in our simulation. In this case it will be a camera, and so inside this we are going to create a chakra file. Let's start first from the Gazebo plugin. Okay, so here we go. This is a file that is able to make the Kinetic camera interact with the Gazebo, and for that we will need the Gazebo plugin like this. And here this is the important thing that we will see in a while. This is the name of the topic point cloud, and here is defined to be depth slash points. Okay, and then you have some let's say hardware setup. So this will be the setup that will be the same to replicate the hardware that you're gonna have. So let's start from this data here. And basically that's all. I have done another specific video for that. I'm gonna put the link in the top right corner. Okay, now let's jump to our URDF chakra file. Okay, here we go. This is the chakra file that describe our camera. And so first of all we need to include the Gazebo plugin chakra file that we have just created, and then for geometry we are gonna use the meshes that we have put in the folder meshes sensors camera. Okay, STL and the AE, this one here. Okay, and then basically that's all. So now we have our camera like a standalone URDF file. So what we need to do is to put this camera inside our robot chakra file. So what we can do here is to modify this UR5 YouTube gripper chakra file, and guess what? We're gonna copy this and rename as UR5 YouTube gripper underscore camera chakra file. Okay, so we can see from the title what this chakra file has inside. That is going to be the robots, the gripper, and the camera. So here we go. First of all, what we need to do here is to include the Kinetic RGBD URDF chakra. Then at the end of this URDF file, we are gonna actually put the camera using the macro that we have created in the URDF chakra file. Here we go. So this is the position in X, Y, Z of the word, and yeah, this is the orientation. And what we're gonna do now is to create our Rviz environment to check what is the position of our camera related to the robots. But I can anticipate you that is gonna be on the top with 70 degrees of orientation in the pitch, but we are gonna see in a while. So if we wanna make a refresh from top to bottom, this Kinetic RGB is a macro that we have created in this file here. This is the macro, and at the end, if we want to to get the name of the topic, we need to check the macro Kinetic RGBD camera gazebo, which is belonging here in this file. And here you can see that the name that we gave is something that we have put it here, and so it goes here, RGBD camera. So I'm gonna remember you that the topic will be RGBD camera, then depth points. Okay, remember that we're gonna check it into a while. Okay, so let's create this launch file. Okay, here we go. We load the chakra file as a ROS parameter in the robot description, and here nothing new. So let's launch this file and see what is the position of the camera and the orientation in respect to the robots. So let's run. Okay, here we go. You can see the camera is here. Let's bring the shoulder lift on top to see if we have a collision, and it seems not. Okay, this is something interesting that I wanted to you to check. So this is the frame of the camera. So this is gonna be the Z, and this will be very important because we are gonna use this orientation in our manipulation of the 3D image. So this will be the Z direction, and we are gonna see in the next video why this information will be important. And remember that the camera is pointing at 70 degrees from the top. Okay, so from the top here you're gonna have 70 degrees here, and so the camera will be able to check what is gonna be in this direction. Okay, so we have installed our camera. We have checked where the camera is. So every time I remember you that you add some features, some geometry components or sensor in your URDF file. If you want to run into simulation and play with the MoveIt motion planning plugin, you will need always to modify, or in my opinion is better to create another MoveIt configuration package using the most updated Shackle file. So this is something that we're gonna do it now. In our series, we have done this a lot of time, so I'm gonna go quickly, but I'm gonna put the link in the top right corner of this video in order you to check. The different things will be the 3D perception that we are gonna do it separate, and we're gonna see in a while. So let's create this package. Okay, so we have created our universal robots camera YouTube MoveIt config. And as always, we're gonna have the um, configuration folder and the launch folder. And as always, what we're gonna do is to modify the ROS controllers in such a way that we can include our namespace as we have seen in the last video, and then we're gonna create another file that describes the kinetic camera, and we are gonna launch this in the launch file that we're gonna create. So always the same procedure, but for the controllers this we have already seen, but for the camera this is the first time that we're gonna do it together. So let's do it first. The ROS controllers. Here we go. This is the configuration of our joint for the robots, the UR5 and the gripper. And now what we're going to do is create another configuration file, and let's call it sensor kinetic point cloud.yaml. Here we go. This is the description of our sensor and how this sensor or this depth camera is interacted with the world in Gazebo. And this is the point cloud topic that we have seen before. RGBD camera depth points. Okay, and this topic will contain a data of type point cloud 2. This is very important to bear in mind. So if you're gonna use the setup assistant for the perception, this configuration will be appearing here, but since that we have a specific point cloud topic, I suggest you to create another file and call it creating another file as well here. So this is what we are gonna do, but first let's create a launch file for the custom ROS controller configuration file. Here you go. And then now we need to modify the universal robot MoveIt control sensor manager. This is empty as we expected, so let's populate this. Okay, and basically what we need to load is the sensor kinetic point file that we have just created, that is gonna be this one. Okay, and here we need to configure just a little bit, so we need to configure the reference point of the octomap frame, that in our case will be the word, then the resolution of the octomap, so how we're gonna resolute and we're gonna create some cube from the point cloud topic. And then the maximum range, this is gonna be 5 meters, so beyond that we are not going to see the octomap. Okay, that's all, so it should be everything to launch. And but now what we're gonna do is to create a launch file where we are gonna spawn our robot, our camera in our world, and we interface with MoveIt, and actually we're gonna see what the camera is seeing in terms of 3D perception, and in particular in point cloud. So let's do it. Okay, let's go in our Universal Robots YouTube application here, and let's create another launch file, and we can call it spawn UR5 gripper camera launch file. Okay, so here we go. This is the same structure that we have seen a lot of time in our series, where we are gonna load as a ROS parameter the robot description with the latest chakra file. Then we're gonna set up the position of the base link in the with the reference of the word, and here we are going to load our word file. So I have done offline a simple industrial environment where I'm gonna put a table and two objects inside of that. I'm gonna send you the link of how to structure a Word file in the top right corner, with the word model, with the words and the models. Okay, so nothing new here. Then we need to load the controllers that we have set up in the last video. So we're gonna load the UR5 gripper controllers YOMS file, which is gonna be here, and this is of type, I remember, your effort controllers joint trajectory controller, with the PID value associated to each joint. And then we are going to open Rviz with the MoveIt motion plugin. Okay, so let's launch this file and see what happens. Okay, so Gazebo is opened in the pause. So yes, this is something that will need to update. So just move the object in the just in the right, so to avoid that it's gonna collide. Okay, don't worry, I'm gonna put the link of the industrial environment package in my GitHub repository. But basically, this is a representation of an industrial environment that could be. Imagine that in this table you're gonna have a belt conveyor, whatever, but to play with the statics for the moment, let's assume that we're gonna have just a table, and we want that this camera is able to recognize this object here, which is a cylinder, and the cube here. So if we press play, you're gonna see that Rviz is gonna open. Okay, here we go. Okay, so we can see that the camera is pointed directly here, and now let's check if the robot actually, if we wanna ask the robot to go in the upper position. Let's see if the motion planning works. Okay, it seems to work. And then what we can do now is to check what is of type point cloud that this camera is subscribing to. So let's add another type of message. Here we go, point cloud 2. Let's open, and then what we need to do here is to check what the camera sees. So to do that, we need to go to topic and then select the RGBD camera depth point, which is the same that we have configured in the Gazebo plugin. So let's select. Okay, here we go. This is what our camera is actually seeing. So it seems that so let me open here. So it seems that it's gonna be a 3D image, but this is a representation of points. And if you're gonna zoom in, we can see that there will be some points. So in your application, depending of your hardware computer that you're gonna have to play with this application, is gonna be if you see the point cloud values in Rviz is gonna be very low, because you can imagine that this Rviz needs to play with the motion planning and then also image recognition in 3D, process all these points. So it's not a good practice to do that. So what we can do is, for example, to process the data that the camera sees using the PLC ROS, and so in order to have a PCD file. So let's run it. So before to start, make sure to download in your workspace all the point cloud library stack software. I'm gonna describe in the description down below how to do that, but if you go to the pointcloud.org website, you're gonna see very easy how to do that. So for now, what we can see here is to open another terminal, and we can run the PCL underscore ROS plugin. So for example, let's go to our workspace. Okay, so now what we can do is to ROS. So let's do a ROS topic list. Okay, and check what is gonna be the topic that we are interested to. And the topic that is of type point cloud 2 is going to be this one, because we have set up in our gazebo plugin. Okay, so RGBD camera depth points. So what we're gonna do is to run PCL ROS, and we are going to create a PCD file, a point cloud data file that is representing this 3D environment in terms of point cloud. So ROS run, then PCL underscore ROS, then point cloud to PCD, and then the input of the topic that we want to check is the one that is subscribing the Kinetic camera that we have just installed. Okay, and you can see that every few seconds some files is going to be saved. So let's close it for the moment, and then if we go in this folder, let's check. So we're gonna have this free file here. Okay, it's streaming. So since that we are not doing nothing, all these three files will represent the same things. So let's see what is this point cloud data. So to do that we are gonna use the PCL viewer. So we're gonna type in the folder that we have these PCD files, PCL viewer, and then the name of the file, that in our case is gonna be 27 35 73 000.pcd. Okay, it's loading. And here we go. This is exactly what the camera is seeing at the moment, and you can manipulate this PCD viewer much easier than in Rviz. So again, as I mentioned, if we zoom in, we are gonna see that this environment is gonna be represented by points. Here you can see the points, but since that they are very close between each other, your eyes can see a solid figure. But you can see that each point, if you continue to zoom in, is represented by a coordinate in x, y, z related to the frame of the camera and the data RGB. So you can check what is the color of this point. In this particular case, it's going to be the table, it's going to be blue. And basically you know how to and basically now you know how the point cloud data is shaped. And basically now you know how the point cloud data is made related to a real environment. Okay, that's all for today. I hope that you enjoyed this video. If you like this video, subscribe to the channel and put in the comments down below what is your robotics application, and if you have an application that you struggle with, feel free to reach me out and book a free call with me. I'm gonna put the link in the description down below, and don't forget to check out the advanced ROS course that is able to bring you from zero to a robotics software engineer. And I'm gonna put the curriculum outline in the description down below. And now we are at the pre-selling phase with 75% off. So feel free to check it out, and if you have some question, don't hesitate to reach me out. Okay, again, thanks for your attention, and as always, keep learning robotics with Ross.